I'm Warren.
And I'm Latonya.
And this is
Limits
and Asymptotes. Number 1. The limit as x approaches 0 when tangent 2x over x. So first you plug in 0 to see if that works. Which equals 0 over 0, and that is undefined. So then you have to make this look different so that you can do it. And we learned that if you have sine theta over theta, then that equals 1. And we know that tangent is the same thing as sine over cosine, so we can rewrite this problem as the limit x approaches 0 sine 2x over cosine of 2x, and then make sure you put this x, which is this one, because this is the same thing as tangent of 2x, and then you just bring the x right along. And so in order for this sign to become 1, you have to make this sign of 2x have a 2x in the bottom. So how are you going to do that? You have x right here, so let's just multiply this whole thing by 2 over 2, which then gives you the limit x approaches 0 times 2 sine 2x over 2x, just to make the visual easier, and then we'll go ahead and write 1 over cosine of 2x right here. And once you have this, it leaves you with limit x approaches 0, and this becomes 1. So I just left with 2. So 2 times 1 over cosine 2x okay. And so once you work from the problem looking like this to like this, you start to solve to find the limit. And to find the limit, you just plug in 0 for x. And because we know the unit circle, we know that cosine of 0 is 1, which leaves us with 2 over 1. So the answer is 2. Okay, number 2. The limit as x approaches -8 from the right for the function 2x over x plus 8. So when you plug in -8, which equals -16 over 0, and that's undefined. So we know that we need to do this problem a little bit differently. And because this problem, you're figuring out the limit of -8 when it's approaching from the right, when you look at a number line, you see that it's -8, -7, -6. So if a graph is approaching from the right-hand side, then you can pick a number, say right here, to figure out what the limit of -8 is approaching from the right. So I'm going to use -7.5. So we'll do limit x approaching -7.5. I forgot. So then we're going to plug that into 2 times -7.5 over -7.5 plus 8 equals -15 over 0.5. And because this is just approaching from the right side, and we know that the limit of -8 is just not going to exist, then we can assume, or we know that this graph, wow, that was ugly, negative infinity. And for the vertical asymptote, we know that it's going to be x equals -8.
Number 3. The limit as x approaches infinity of 4 minus 3x squared over the square root of x to the 6th minus 9. So first of all, we're going to try it. We're going to plug in infinity. See what we get. It's going to equal infinity over infinity. Now, we can't do that. So what we need to do is make the problem look different. So we'll write it again. The limit as x approaches infinity of 4 minus 3x squared over x to the 6th minus 9. So what we need to do first is find the highest exponent, which is x to the 6th. Now, we would divide by the highest exponent, but in the denominator there's a radical, so what we can do to the top is pretty much do what the square root of x of 6 would be, which would be x to the 3rd. So, let's see how this goes.
4 over x to the 3rd minus 3x squared over x to the 3rd over the square root of x to the 6th over x to the 6th minus 9 over x to the 6th. So 4 over x to the 3rd minus 3 over x over the square root of 1 minus 9 over x to the 6th.
Now that we're at this stage, we can start to plug in infinity.
Which would equal 4 over infinity is 0 minus 3 over infinity, which is 0. 1 minus the 9 over infinity is 0, which equals 0 over square root of 1, which equals 0 over 1. Therefore, the limit is 0, and the horizontal asymptote is y equals 0. And that is the answer to number 3.
So number 4 has part
Part A asks for the limit when x approaches -4 for the function above. Part B asks for the limit as x approaches -4 from the right. And part C asks for the limit as x approaches -4 from the left. So, to solve this problem, we look at the graph that I have so kindly drawn on the board, even though it's kind of ugly. So, you look at the graph, function -4. Whenever you bring your fingers together to -4, it doesn't touch any point or any line. So, it's safe to say that the function does not exist at -4. From -4 approaching from the right, we're approaching from the right. Oh, check this out. Here's a line and it's going up. So we can see that x is going up forever and ever. So we know that that is positive infinity. And for when x is approaching -4 from the left, so that's this way, all right, gets to -4. Oh, here's a line and it's going down, down, down forever. So it's negative infinity. Number 4.
Number 5, part A. The limit of f of x as x approaches infinity is -1 because as x approaches infinity, the line approaches -1. Part B. The limit of f of x as x approaches negative infinity is 2 because as x approaches negative infinity, the line approaches 2.
What's 9 plus 10?
21.
You stupid.